I will show today Msty. Oh yeah, I have the Apple reactions. Okay. I will show you Msty, which is a platform to do AI, and it can give you ideas, and it can do retrieval augmented generation for you. We will see that. I just want to show you quickly a few things about Gephi, like how to start some data visualization. And I will also show you how to obtain a network if you have a data table. And if you have questions and you want to know more, for example, if you want to know how to obtain, for example, keywords from text and those kind of things, just feel free to ask. And I will just open the floor for any questions you may have, and I will show you whatever tools you want. And then I will leave this video as teaching material somewhere on YouTube probably. So if you're watching this video from there, just know that the audience here is people who are not data scientists. And basically what I'm going to show is like a show and tell of some tools. And my idea here is that it's not to train you to become a data scientist, but rather if you want to engage with AI, to understand AI, and in this case, qualitative AI, and you want to know more by yourself, you want to build your experience with it and so on, which tools should you go to, right? So it's not to completely use that, but rather to tinker with it so that you understand it better, so that maybe you can better understand how it should be integrated in your organization or something like this. So I will start with Msty. Let me share my screen. Yeah. You should see my screen right now. I hope you see the web page about Msty, I assume. So, in short, Msty is like a platform to do things that look like ChatGPT, but on your own computer. The main difference being that if you have confidential data, it will not leave your computer. And also, full disclosure here, my computer is a Apple MacBook with the M2 chip. So it's pretty good. I'm not sure how well it runs on everyone's laptop, so you have to try. First of all, Msty is written like this, M-S-T-Y. So you can just Google it. You will find the website, and you should just install Msty Studio. They also have kind of a online thing with some stuff you can access from the web. You have to pay for that. And you will also see that there are some premium features in Msty Studio. I'm going to ignore them. But so what you want is Msty Studio. And so I have it installed, and I'm going to open it for you. Okay. So let me just demonstrate. I'm going to ask a question. This model is running, and it's going to answer this question. And to reiterate, this does not go over the internet. It runs on my laptop. The first time you will open Msty, you will not have a model installed, and it's going to actually prompt you to install a model, but I'm going to show you how to do it generally. So there is this little button here, Model Hub. You can click here, and then you can basically plug some models to it. They could be local models, so you install them on your machine. They could be MLX models, which are like optimized for Apple Silicon. So supposedly this could work better for my computer. I tried and it didn't work for me. I don't know, maybe I did something wrong. And then you have, you can add providers. And so basically the providers could be OpenAI and whatever. There, you have a lot of them. So if you wanted to, you could also buy a service from over the internet, like through an API. You should just go there, you buy some credits on their API platform, and then you can plug them here, and then you can later on choose them. So for example, and I'm not going to do this, but I'm going to install another local model. So I had installed Mistral Nemo, which is the one I'm going to use, but I could use another one, let's say DeepSeek. And you can see that they have a different size in terms of memory on your hard drive and so on. If you just want to install one, just do it. And then it's going to download and it's going to take some time and so on. Once a model is installed, you can choose it from the list. So that means that you could swap models very easily. And so that would be a way for you to experiment with different models. Now, let me show you another small feature that is good if you want to tinker with this. I am going to add another chat next to this one. And I'm going to write, okay, what happened to us in 2000? Yeah. I'm just going to ask it to be brief. And so it triggered the same thing on both sides of Msty. Same model, same settings. And what you should see is that those models are not deterministic. So they can give you a slightly different output every time. I will do it again. Can I delete this answer? I'm going to restart simply, but I'm just going to copy this. What you could do, DeepSeek is here. I'm going to stay with Mistral. So you could compare Mistral to DeepSeek. Or maybe let's do that. You will see that sometimes they beware differently. Also, DeepSeek, I expect, is slower because it eats more computations. As you can see, it's not as fast as if you use that online, at least on my computer, but it's fast enough that you can use it. In case you don't know what the R1 after DeepSeek means, it's a thinking model, reasoning model. So you can actually see what its thoughts. The thoughts are just the model speaking to itself. And then it gives us some information. Okay. I want to show you yet another thing. I'm going to go back to Mistral Nemo. And you have access to the parameters of the model. So let's go to Mistral. And I can change some of the parameters. So this is like this little button here. You don't have to, like a lot of the parameters are, I don't know, probably esoteric for you, but there is one that is quite easy to understand, and it is temperature. So temperature basically means when you add more temperature, it becomes more random. So we could have like a temperature of 1. I think it goes from 0 to 1. And I don't want to send that to everyone, just this model on the right. So this one has a temperature of 1. As you can see, the parameters have been edited because here there is a little, can I zoom in? No, I can't show you. But the little icon has been changed. This is here the default, but I'm going to just also change the temperature and I will set it to 0 if I can. Right, so let's check temperature 1 on the right, temperature 0 on the left. And then I can ask the same question. And maybe this question is a little bit stupid, but basically, supposedly with a temperature of 0, it's always the same thing. Now, some optimization may make the model non-deterministic nevertheless, so maybe it will still change. But it should be more random and potentially more wrong, but also potentially more human if you have a higher temperature. The only thing I wanted to demonstrate here is that you could use this as a boilerplate to make micro experiments, to just make your own mind about certain behavior of the models, comparing different models, comparing different settings, and you can add even more chats. So what I'm going to do now is okay, can I make this one the default? Let me see that. Is there some default setting? I don't know. I wanted to have Nemo propose all of the time. No, maybe not. Okay, I will change it every time. Okay, so with Mistral Nemo on the left and on the right. But what I will do is first I will attach a document. So this is in this little menu, attachment. And I have here, I had downloaded from the internet on my computer, the PDF reports of Ørsted from 2017 to 2022. So I will just upload the PDF from 2017. Yes. And so this guy is attached on the right. So this chat knows this document, and the chat of the left on the left does not. And now when I ask, you will be able to see that obviously the answer we're going to have will be very different, because essentially on the right, it will be able to read through that document and give information from what's in the document rather than from what it has learned from the training data, which is random data from the internet, essentially. Of course, it's demanding for my machine, so we have to wait a little bit. Plus, I am streaming now with you, so you have to be a little bit patient. But very clearly on the left, we have like a priori knowledge, like general knowledge about Ørsted, while here it's extracting a number of things that are in fact in the document. This feature should not be new to you, because you also have it in, for example, ChatGPT or Claude or other like online AI assistants that you may have tried. But this is a segue to something else, which is retrieval augmented generation. So I will create a new chat just to show you. So what I just did before, right now, was to attach a document. In this non-split version, it's just this little button. So if I do this, this will be added to this chat. But there is another feature that is similar but different. It's what's called knowledge stack. So it's just here on the left. And if you click here, you can pick one or more knowledge stacks, and the sound, it does what it sounds like. It allows you to create some knowledge that the model can convoke to answer you sometimes you choose. So that's another way to think of it, but this is just retrieval augmented generation. And I'm going to create one stack. So I will go into manage stacks. It's going to open this interface. And basically, I will just create a new stack. I will name that like Ørsted reports. And then in files, I will simply drag and drop or just upload some documents. So I will do this, and then as you will see, the status is pending. It works a little bit differently from the attachment that I have done before. It needs some processing, so we need to wait a little bit. It should be fairly fast, but still. So what is going on here? Under the hood, Msty is parsing these documents, extracting the text, and maybe the images. It depends, you can parameterize that. Chunking this big text into smaller pieces, storing them in a database using embedding models. All of that is black boxed, so you can parameterize it, but it's also, you don't have to think of it if you don't want to. But what's really important is when we will speak to the model, it's going to query this database to convoke some chunks, and those chunks will participate to the response. What's the difference with the attachment? Well, when you attach something, it is entirely read by the model as part of your prompt. So if you have a really big document, it may exceed the token window, so the maximum size of information that a model can read. So then you're stuck. While with this system, you can have much more information because it will be parsed and chunked and stored in a database. And then when you speak to the model, the query will give you the most relevant documents or chunks regarding your request, your query, and it will assemble them into something that the model can read. So like a virtual attachment that contains just the chunks that are relevant to your question. Should I do, maybe I should have clicked on compose, I don't know. So this, yeah, I should have clicked here. This will create a knowledge stack. I'm going to close this here. And then when the stack is open, it's going to appear here in my knowledge stacks. And so the same way I can attach a document, I can check and uncheck which knowledge stacks I want to have. So they are like multiple folders containing documents. If I just go back here, so this one is being processed, it's almost done. You have a list of kinds of documents it can read. It's many kinds. PDF, CSV, Markdown, JSON, Excel, Word, and PowerPoint, right? So you can have a mix of documents and you can basically dump very big quantities of information. Once again, this stays on your computer. I would demonstrate that by shutting down the internet on my computer and it would still work, but I would also lose the connection to you, so I will not do it. Just note that if you use Obsidian Vault, if you use Obsidian, which is kind of a note-taking environment, to put it shortly, it also has similar features. You can also connect to these, to this. So if you don't know what I'm talking about, either ignore that or just take a look at Obsidian. I'm not going to go down that rabbit hole, but if you use Obsidian, it's good to know that you can plug to it directly. So now my Ørsted reports is there, and if I want to have it here, I can just check it. And then if I ask once again the same question, it's going to retrieve this from the PDFs that I had uploaded. So I don't have to attach the document. It's going to go there. But something else is going to happen, which is that you will be able to see which chunks were retrieved. And this will be really important because, as you know, models hallucinate. So I've asked the model many times different things. I am not sure that they were right. Maybe they told me completely wrong things about Ørsted. Even when I attach the document. When I attach the document, it has better information, but it can still hallucinate or misread if you want. But you're never guaranteed against that. Now, with the knowledge stack, and this is a critical difference to me, that looks like Notebook LM, if you're familiar with how Notebook LM works, is that you can actually unfold and see by yourself which chunks, so they call it content here, which chunks have been retrieved, and you can read them. So you can basically use this as, you can use the generated text by the model to get an idea of if the answer is good or not, but then you can double check. So for example, if I click here, I can read this chunk. So it's an excerpt. It's a little piece of this big PDF. Of course, you don't see it as a PDF because it has been transformed into text and so on. So you see basically the verbatim extracted from the PDF. Yeah, but that is what it is. So I believe so I've not experimented with that that much more. I think I have seen, can I see this? I have seen that you have some amount of configuration that you can tinker with. Yes, okay. So you can change the chunking method. You have access to some parameters. Is it only in the... Yes, okay, that's good. So this is something you may want to tinker with, because depending on the kind of information you have, certain sizes, like maybe you want to have smaller chunks or bigger chunks. These kind of things are relevant sometimes. And all these settings, you will understand what they do simply if you've followed my previous explanations about retrieval augmented generation. But essentially, they are about how you chunk the documents and then how you retrieve them from the embedding model. So for example, the similarity threshold is how close you want the chunks to be regarding your demand, your query. So if you go low, you will have only very, very similar chunks. If you go higher, you will have less similar, but more chunks. Okay. So, and Msty does yet other things. I'm not going to talk about them. This was mostly what I wanted to demonstrate. The takeaway here is Msty is a boilerplate to do micro experiment and tinkering with large language models. And it can also do retrieval augmented generation like Notebook LM, but all of that on your own laptop. So you can give it information that is confidential or sensitive and so on. Do you have any questions about Msty?
I got a connecting question. I think the RAG thing. If Msty, I didn't know you could build that on your own computer. That's pretty cool. But do you know if, for instance, ChatGPT, ChatGPT had this function called projects, and I think Claude has something similar. Mistral has something similar. Is that also RAG? Do you know that? Or
I assume, I don't know for sure. I'm pretty sure it is.
Yeah,
so don't quote me on this.
No,
but
yeah.
Yes, RAG is really a standard feature. It was something that everyone was doing on their own computer, but was not integrated per se in those systems, because as we discussed, the AI assistants like ChatGPT, they are systems. It's not just the large language model, it's also all these modules they add over time. But I'm pretty sure that this is coming in that way. Yeah. So I'm pretty sure it is. And the way the feature tends to be implemented is with separate silos that you can draw in or not. So like the different stacks you have here, and you can them all or some of them. And it often will look like that. So also to say a word about Obsidian, which I don't use personally, but I just know it's there and it does similar things. So Obsidian, basically the idea is that you would take your notes in Markdown, which is like a simple text format that is not as complex as, say, Word, but you can still do a little bit of formatting like bold and titles. And so you would store your nodes as Markdown. This existed before LLMs. Obsidian is not LLM, an LLM thing in the beginning at least. But now they have this system where you can do RAG on your nodes, which is obviously a good thing to do because it helps you navigate and discuss with your own nodes. And they have also chosen to allow you to create separate projects. That's what they call vaults. They are just different projects or different knowledge stacks. Any other questions about this? I will then be moving on to other stuff. So, where is my browser? Here it is. Okay. I know I see some. So you use Obsidian, Tom. I'm just reading the chat now.
Yeah, but just as a note-taking thing, I didn't know it could connect to Msty.
Okay.
I use it for all, personal notes and professional notes, all kind of.
It was made for that.
Yeah. It's
okay.
It's free.
It is free, absolutely.
Yeah.
And so is Msty for now, at least. And but also why? So we're recording that in October 2025. If you watch that from the future, maybe it's going to be funny. I don't know how this is going to evolve, but it costs money to run those models. My laptop has been using energy like if it were playing a video game, basically. And this is all fine. But obviously, having ChatGPT for free costs a lot of money. So there is this data sensitivity question that you don't want to share with OpenAI and so on. But there is also the question of the costs. And so a lot of things that are free now may not be free in the future. And that is why it's a really big security thing to have those technologies be able to run on your laptop, because worst case scenario, it works at home. And now you can use it on your own. You just needed this middleware that is Msty, if you want, that is making the connection between you and the model. But now it's really easy. Also, if you have Ollama models installed, which is another environment where you can also download some models, Msty can read your Ollama models. Not this works all the time. I just have to say, I tried Msty and some of the things didn't work very well. They are updating it all the time. Everything is moving right now, obviously. But I'm really confident that this is gonna stay. And even if Msty went to go fully to pay for, I guess there would be an open source alternative emerging. Let's see how it goes. I will now move to Gephi stuff. So sharing my screen again. Gephi is a software to analyze networks, and you can find it by Googling Gephi or just going to gephi.org. And you can either download the desktop application or you can use the online version. So I'm going to just show you what the online version looks like. It works in your browser, so you don't need to install anything. This is really useful for people who don't have the rights to install anything on their own computer. If you have just the HTML5 browser, it's going to work. And if I load a ready-made network, you will see what it looks like. You have these circles that we call nodes and represent items or beings. In this case, they represent the characters of the Les Miserables novel by Victor Hugo, but they could be anything. And then you have those lines that represent connections between these elements, these items, these characters. We call those lines edges or links, if you prefer. And a network is made of nodes and edges. These structures exist independently of you visualizing them, but if you want to visualize them, essentially what you need to do is to place them in the space of the screen or the paper sheet if you print, so that you can read patterns. And the patterns that is the most important with networks consists of clusters. So we expect to see most of the time, if your network is very small, maybe you just want to be able to follow the connections. Fair enough. But once your network becomes big, or if your network is complex, like this one is, so very entangled, then what you expect to see is where the clusters are. So this is like in yellow, for example, it looks like a cluster in the sense that it's a bunch of nodes that are next to each other in the space. And if the layout is well made, then when those dots are close to each other, it means that they tend to be more connected with each other, directly or indirectly. So if I go here, for example, when I highlight a node, I can see to whom it is connected. So Ptolemaeus is connected to Favorite, Farneuil, Blacheville, Dahlia, Listolier, and Zéphine. So all of them seem to be connected also to Fantine. And so they are all connected and they are all in the same area. We can double check that they are connected by highlighting them, but basically we know they are connected because they are in the same area. I just wanted to say, sometimes they are not all of them are connected. Let's take one, maybe. Yeah, so here, for example, Montparnasse is not connected to Anselma, but they are indirectly connected by having many neighbors in common. So Anselma is connected to Madame Thénardier and Éponine, and Montparnasse is, not to Madame Thénardier, but to, I guess, Mr. Thénardier. Right, so they belong to the same clusters, even though not everyone is connected to everyone directly. We would say they are just indirectly connected. And yeah, so this is what you see here is the made map. So we do see the clusters and we have colors that help us see this. But essentially, if you load a network that has not been worked, you will not see those patterns. And the purpose of Gephi is to generate those patterns. So you will pick a layout algorithm and apply it, and you will pick some colors and so on. Yeah. So let me just open another network. This I had also made it, but I will unmake it. So I will apply a random layout, and I will apply random colors. Color, or let's say I'm going to put all the nodes with the same color, which is going to be gray. So when you load a network, it looks like this, like a square, and and we have different node sizes, but I also want to have the node size be a constant thing. Yeah, good enough. Okay, so this looks like what happens if you open a network that has not been visualized. And I'm going to go through the process very quickly. The first thing you would do is apply a layout. So in Gephi Lite, it's going to be here on the left, layout. I recommend you use Force Atlas 2 because it's the one that, if you just push start, it should work most of the time relatively easily. And then everything is going to move until the positions settle. Metamari, you have a question? Yep.
Yeah, I was just wondering about the data you loaded, because have you tokenized in sentences or
Nope.
documents or
So
what?
let's say, so very important, this is a network. So it has nodes and edges. You don't know what it is. We will discover together what it is. But Gephi starts from the moment you have nodes and edges. If you have text, Gephi cannot open it, right? So Gephi starts working from the moment you have extracted a network, and there are many ways to do it, and this is on you. And I can then.
Oh, I just wanted to see the data set just to get a quick view at the data.
Yeah, I will show you the data then. But there is no.
Oh, there's a data section instead of the graph.
So let me just open the same network with Gephi desktop. Oh no, okay, we have the data view here. My bad. This is new. Sorry. So the Gephi has two versions. This is the desktop version, the one that runs on your computer. It can handle bigger networks, and then there is the online version, and we are developing both at the same time. And Gephi Lite has just had a lot of evolutions very recently, so I had forgotten that we had now the data table accessible in Gephi Lite. So essentially, this is what the data looks like. I'm not opening the file itself because it's XML, so it's not going to be very readable to you. But essentially, a network is two lists, a list of nodes. Those are the nodes, and they have some attributes, and a list of edges. So edges are connections of nodes between two nodes. Okay, so this is what the data consists of. It doesn't consist of X, Y positions and so on, right? So the layout has to be generated. What I call the layout is the position of the nodes. So to see the patterns, first we will run the layout as I have done here. So now we have kind of a shape for this network. Then there is a lot of know-how about how to make a better network visualization with the layout, how to set it and so on. I'm not going to go down this rabbit hole, but you will find many tutorials and videos online that explain to you how to do that, including some made by me. And then I would like to emphasize information. So can you guess what this dataset is about now? So if I just go on some nodes, you can see what they are.
Connected airports.
Flights between airports.
Yeah, okay, you're both right. So airports connected when they have a flight connection. So the nodes are airports in the world, and the connections are the existence of one or more lines, flights that connect one airport to the other. And as you can see, there's a lot of like the visualization is very cluttered and difficult to read. That's because we would need to have some emphasis on certain nodes and not others, just for the sake of not having to see everything at the same time. So what I will do is I will give different sizes to the nodes, and there are different parameters that I could use here. So there is one that is called size. Maybe that's I don't know what size means here. I would have to go into the data where I have downloaded that from the internet, so I would have to read the documentation of the dataset. But so I don't know what that means, but latitude is typically, where the airport is in the world, longitude as well. These are not good ways to emphasize my airports, because I don't think that if you have a higher latitude, you are more important. But one that makes sense to me is degree, and degree is network language for number of connections. So we could discuss why using this, but I'm going to just make the call now. If you have more connections, I'm going to say you're more important. And we could discuss that, but I will not. What's really important to me right now is that now certain nodes are big. Can I just hide the labels temporarily, or shorten them maybe? Because there are too many labels. But essentially, you have a few big nodes and a lot of smaller nodes. So that helps us emphasize information, because Gephi displays the labels depending on the size of the nodes. So if you have smaller nodes, they will have their label displayed less. That's one way to improve the visualization. Another way is to have node colors. So I could use the color by... I could do country, but my issue here is that we have too many countries. But I think we may have something else. What is DST? Yeah, okay. DST is better. So these are kind of big parts of the world. So I guess they are like north, south. I don't know exactly what they are, but we have less categories. So green is E. Would it be Europe? Maybe those are the continents. I don't know that enough. So yeah, so that was DST. If I use country, we can try. Yeah. Then Europe is really spicy and colorful because we have so many countries. So I don't want to dig too much, but the kind of thing you would say is you would try to look at where the clusters are. So for example, we have a cluster here. We see it. It's not a question of colors. It's a question of whether the dots are together. This looks like a big cluster. This looks like a big cluster. This looks like a big cluster, and then we can try to understand what they are. So if we just look at some labels here, okay, so this is clearly China. Big cluster here. What is this? Malaga, Palma, Barcelona, Amsterdam, Charles de Gaulle, Frankfurt. So it's Europe, and it's a single cluster, even though it has many countries, which is one of the observations that are worth making. It is not a groundbreaking. We kind of know that. But basically, we are comparing where the colors are to what the clusters are. Because if we compare to the USA, for example, so this is here the USA. And the USA is one country and one cluster. Even though if we look closely, we'll see the blue ones. So what are the blue ones? So maybe they are, I don't know, I'm assuming that it might be Mexico. And maybe we have Canada somewhere. We can actually just click on a node to know. Label, blah, 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 city, Monterrey, country, Mexico. Okay, so this is Mexico. And what is Canada? Is this Canada? Yeah, Calgary. This is Mexico. This is Canada. Country, Canada. So, observations, North America and Central America are one cluster. Europe is one cluster. China looks like it is one cluster. And then we could discuss. So for example, would we consider all of this as a macro cluster? Yes and no. Like, this is nuanced, right? So one of the reasons to do this is you get some nuance. You can interpret. And for example here, so what is this? Penang. I'm not that good in geography. Let me just click to see. So Malaysia. This is Philippines. This is Australia. This is Japan. So they are less all together than Europe, but they are still relatively more connected than to the rest, which is another way. How do I know that? I can see that from the links, but also from the position of the dots. They are like subclusters of a bigger cluster. I hope you see that with me. So I could make both cases, and it's a little bit of both. They are at the same time a little bit of a cluster, but less connected than Europe. And they are a little bit of different clusters, but then you would have to say those different countries are still more connected with each other than they are with the rest of the world. So that's the kind of interpretations you make with networks. And I think I'm going to stay here for Gephi and move to how do you get a network if you don't have one. But maybe you have questions at this point. Yeah, Tom, you have a question, maybe?
No, I think I'm more into, I think how to get the network is, I think it's more, to me, this is, there's a lot of experimentation in this,
Yeah.
which I guess is fine. That's you just have to sort of be aware of that this is not giving you the answers, but it's sort of helping you mog around and then probably at some point find something that you, yeah.
Absolutely. And let me then state it explicitly. You would go to network visualization because you are interested in relations more than the substance of your elements. Because if you let's say you are interested in airports, but the kind of questions you have is, what are the most visited airports? You don't need the connections for that. You can just go to an Excel table of metadata by airport, and then you will use normal statistics. The more difficult questions are like, what are the clusters? So if you want to make groups, and you would be like, but should I put Australia in the same group as Asia or not? Is there a strong cluster with oceanic islands and so on? Indonesia, and so maybe the Pacific area, the islands in the Pacific make a cluster, and maybe they don't. Should you group them or not? This is a question you can have from the network, because the table in Excel will never give you this information. Another example of of questions you may have an answer from networks is who is central and who is peripheral. And maybe an even better version of this is who is a bridge and who is not a bridge. In sociology of social network analysis, sorry, you may have the notion of broker, for example, which is the intermediary. I'm sorry, Jonas, Jonas is gone. So being a broker, so being the intermediary, makes you important in the network, because if you disappear, some parts of the network cannot connect to each other. That's what it means to be a broker. You're the mandatory passage point. And it doesn't mean that you are highly connected. You may be relatively loosely connected and yet be important. So if that is what you're interested in and you want to identify people who are like that, or items or elements that are like this, networks can help you. A practical example of this, and this is actually a segue to what I'm going to show you now, is in science, you could make a network of authors that co-publish together. And you may have labs where everyone co-publishes with the other people in the lab. But what makes you a different kind of researcher is if you're the kind of researcher who collaborates across the fields. There are not many researchers who can publish with people in very different fields. And those would typically be the innovators, the one who create new, like groundbreaking new knowledge because they are connected, otherwise separated fields. And it doesn't mean you publish a lot. It's completely different. So if you want to identify those innovators, you may have to go to network analysis. And actually, so I want to use a data set about science. Let me just show it to you. Because first of all, bibliometrics have been the classic case for networks for a long time because it's well-structured information and we need it in science, but also it's easy to understand. So I have here a table, a normal table that is not a network. It's just a list of papers. So the columns describe the metadata of the paper. You have the authors, separated with a comma, the title of the paper, the year of publication, the source title, which is the name of the journal, typically. I'm just going to jump to other, you have many, many different things, the abstract. But you also have author keywords and sometimes index keywords. This dataset was downloaded from a database of papers. As you know, in the era of AI, all this kind of information has a lot of value. So it's not as easy to obtain nowadays than it used to be. But I'm not suggesting you use that kind of data, but rather data you may have in your organization or from other sources that would look like this. So basically, I want now to transform this into a network. That's what I'm going to show you. For this, we can use a tool I've made many years ago that is called Table2Net, because it transforms a table into a network. You can just, Google Table2Net and find it. And basically, it's a mini one-page website where you upload your data as a table, and you will download the network. Nothing goes away from you. I'm just using the web as a platform for the calculations, but it's not uploaded anywhere, right? So I could actually also shut down the internet now and use it. It's completely offline. It's just that basically the tool is downloaded in the browser, but there is no server involved. So I will upload my CSV here. It has to be an actual CSV with comma as the separator. You can double check here that it is properly parsed. And basically, you have to choose which kind of network you want. So with information like this, there is not like one kind of network you can extract, but many. And the first point of decision we have to make is whether the network has one kind of node connected with something else or two kinds of nodes connected to each other. Let me exemplify this. Because we have a list of papers, so first of all, the nodes could be the paper. So we could have a network of papers connected with each other, but we will have to say what makes them connected. So we could say they will be connected if they have an author in common. So that's one way. But we could also say, I want the authors and I want the papers connected when the author is an author of the paper. Different way to show it. So basically, this is what this represents. Do you want paper and paper connected by authors, or do you want paper connected to authors? That's what this is asking you. So do you want a normal, a regular, like it's called one mode network, or do you want a bipartite or two mode network? So we can do both, and you can go into the interface and tinker, but basically I'm going to say, okay, normal, which columns should define the nodes? So let's say I don't make a network of papers, but rather a network of authors. We'll take authors. Oh no, maybe because the question was also about where to get words from text. This is not exactly the same thing, but similar. I am going to make a network of keywords. So author keywords. And now what happens here is that in my data, the column author keywords contains a list of keywords. So within a given cell, I have all the keywords. Let me just show you how it is in the source data. Author keywords, you have a list separated by a semicolon. And actually, even here, sometimes the separator, this is the internal separator within the cell. It's not separating the cells from each other. It's within a cell. So here in this column is the semicolon, but if you look at the authors, they are separated by a comma. Right? So that is why when the software is trying to parse this, it finds these long things. This is not what you want. So you have to specify that here the internal separator is the semicolon. And now it is properly separated. You can check this here. So, okay, I have the author keywords. Good. I'm going to skip over having attributes in my network. Which column defines the links? Well, so my author keywords will be connected when they have in common the paper, when they appear in the same paper. And what I can do here is I can just use the row number, because each row is a paper, but else I could use the title. Except that if two papers have the same title, it will create something weird. So maybe row number is better. And then the row number doesn't need anything else. So good enough for me. And I'm going to skip the rest. You don't need the edge weight. You don't need time series, but we could use the year. But I will not do this. Too advanced. And then I can just download it. And yeah, now I have it. And I can open it in Gephi. To open it, I have to. On the Mac, it's kind of broken. Network. Yes. So the interface is slightly different from earlier, but basically I will be doing the same kind of things. I will just pass very quickly on this. But you see the keywords. And obviously, my dataset was about climate change, so the keyword climate change is very central here. Okay. Yeah. So that was a one-mode network. Let me just do it again with a two-mode network just to show you. If I upload the same CSV, and now I will go bipartite, so two-mode network. The first kind will be, let's keep, for example, author keywords. I still need to separate them. And then the other type could be the title. But I could also choose the authors. But let's just go with the title because it's simple. Good. Whatever. This is there. Now I'm going to open it with Gephi Lite this time for consistency. Yes. Open. Here you are. And let me just do this first. The color of the nodes could be the attribute type, which is either author keyword or title. So the green, which can I change this color? Is not nice. Yeah. So the blue ones, attribute title, type title, sorry, and author keywords in pink or purple. And now I could do what I have done before. So for example, the size would be the degree, and let me apply a layout so that we see what the clusters are. Yes, and the only thing that is really, let me say this this way, in a bipartite networks, you don't have connections between nodes of the same type. The author keywords cannot be connected to author keywords, and the papers cannot be connected to papers. The connections are exclusively between one author keyword and one paper, which we can see in data. It's always one purple and one blue. And I think it makes sense given how we've made that. But you can see that, for example, we have like this big continent in the middle with a kind of, you may think of it as a cluster, but we could discuss whether or not it's a cluster. But you have then disconnected islands that are groups of papers that do not share any keywords with the central group. That would be the kind of interpretations you do. So that was Table2Net. This will work if you have tables with multiple sorts of categories, right? So the table that would look like this list of papers where you could have for each item a series of tags, for example, that would qualify this item and that it would have in common with others. If you had a list of documents and then a column with the list of keywords in those documents, for example, extracted named entities, then you could go through Table2Net to do the same thing. The question would be, how do you extract something from documents? Then you need yet another software. And that software could be Cortext, for example, or it could be Script. I can actually show you some of them. I have made this website for another course, which is the course on controversy mapping with digital information. This is the URL. I will paste it in the chat. If I find the chat, where are you, chat? Here you are. And if you're online, I will paste the link in the description of the video. But you can just go to notebooks from this website, and then you have a list of notebooks. And basically this website is just teaching material that explains how to use those notebooks. So you have different things that you can just look at it. There are some tutorials. You have a video of me explaining the basics of Tableau, for example. You have a lot of things. But all of those scripts organized into this kind of big map. Let me show you what's relevant to you. You could, for example, documents with text to word list. So if you have a list of documents where you have the plain text and you want to extract words, you can use these notebooks. It's a Jupyter notebook. It's the pizza notebook. Every notebook has a name, but it also has a small icon for you. So you can just go right now in the list of notebooks. You look for the pizza one. It's this one, documents with text to word list. It does what it says. And if you click there, oops, maybe I should not click here rather. Then it will open in Google Colab. We've talked about Colab before. I'm not going to explain here what it is, but basically in Google Colab, you have the how-to. You can read what it takes to use, what the kind of input you need, what kind of settings here you could edit. And basically here you can extract the named entities or just the words. I'm not going to go to explain what a named entity is, but it's like whatever a person or a place or an event are named entities. So you could extract named entities, or you could just extract all the words. And you could also have other pieces of software that make other extractions. And then you would obtain a table where your documents have the extracted words or named entities or parts of speech or whatever. And then you can go into Table2Net and make the network. And that's essentially what I have for you. I'm not showing you super black box system like Cortext, although we could do that in another session if you want. But because I think that it's more useful to understand that those are kind of bricks you can assemble in any way you want. They are not that mysterious.